Here we want to calculate the 95% confidence interval of a proportion. And this proportion is actually a count of data, but put into correlation or into relationship with a total number. So here's an example. For example, we have 72 individuals, maybe butterflies or something like that, with a certain trait. Maybe they are blue or red or whatever. And we have a total sample of 331. So 331 butterflies and 72 of them are of a particular color. And we want to know what is this 95% confidence interval of this particular trait in the population. So what we can do is we can calculate the ratio, and the ratio in this case would be 72 over 331. However, because we use discrete data, we later on will use this equation where we have a normal distribution which uses continuous data. We need to do some kind of adjustment. And when we use this equation here, you see that there are some numbers added, +2 and +4 in the denominator. And it turned out this is really empirical. These numbers, they are always the same, +2 to the numerator and +4 to the denominator. This is called the Wald adjustment. So Wald adjustment. And it just turned out that this actually works pretty well for large and small numbers. So let's quickly calculate our proportion for, in this case, let's say success, or let's say green or blue butterflies. So we've got 72 plus 2 over 331 plus 4. And we can calculate that equals 74 over 335. So that would be our proportion of the butterflies in the whole population, 22.1%. And now we want to calculate the confidence interval, which we have given here. We can, first of all, we can calculate the standard error. So we can calculate the standard error, which is this part here in this equation. So let's quickly do that. So the standard error would be equals the square root of what we just calculated, this value, times 1 minus this value. And we divide that by our total number plus 4, which we can easily do, 335. And we close the bracket here. And we get the standard error of 0.02266. And now we can calculate the lower bound. So the lower bound, and for this we just make this a little bit larger. The lower bound, we just simply use this equation here and say equals the adjusted ratio, that's what we calculated here, minus 1.96 times the standard error that we just calculated. That's this one here. So that gives us 0.1764. And for the upper bound, you make this a little bit larger so we can see it properly. we do exactly the same calculation, but this time we add this standard error times the z-score, which is the margin of error. So equals the value that we just calculated for our adjusted ratio plus 1.96 times the standard error, and that is this one. So our 95% confidence interval for this proportion would be between 17.6% and 26.5%. So just from this sample, we would argue that between 17.6 and 26.5% of the butterflies or whatever we are looking at have this particular trait. Now, of course, it's a little bit painful to do all these calculations, so there is a really nice online calculator. And here is the link to the online calculator. We need to make sure that we are in the correct format, which is here under chi-squared test, because at the end of the day, this indeed is a chi-square test, or a modification of the chi-square test, and all we need to put in is the number of individuals that we had here, so that was 72. In total we had 331 individuals, and we get immediately our values here, 17.6 to 26.5, and again this tallies very nicely with the calculation that we have performed. So I hope this makes sense, and thank you very much for watching.